Oversizing and undersizing a pump can have performance consequences, so you ought to stay as close to the duty point as possible. Now, let's take a look at a couple of common pump curves, namely the QH curve, the ETA curve, the P2 curve, and the NPSH curve. Together, these four curves provide a good overview of the performance of a specific pump, so we recommend including them in the same datasheet. In a QH curve, which measures the flow and head, you can see that a low flow results in a high head and a high flow results in a low head. Once you have identified the requirements for your application, the flow, Q, and head, H, will help you determine the overall dimensions of the pump. In this example, you can see that a flow of 71 cubic meters per hour equals a head of 42 meters. An ETA curve highlights a pump's efficiency. The total efficiency is the ratio between hydronic power and supplied power. This figure shows the efficiency curve for just the pump and for a complete pump unit respectively. It is worth noting that the efficiency is always below 100%, as the supplied power is always larger than the hydronic power due to losses in motor and pump components. This is why the efficiency of a complete pump unit is lower than the efficiency of just a pump. Next, there's the P2 curve, measuring the relation between a pump's power consumption and flow. The pump's power consumption determines the size of the electrical installations which must supply the pump with energy. Power consumption also depends on the density of the fluid. If the fluid's density is higher than that of, say, water, motors with a correspondingly higher output must be used. As you can see here, the P2 value increases when the flow increases. Finally, there's the net positive suction head, or the NPSH curve. Since the NPSH appears in meters and not kilowatts, it is not necessary to take the density of different fluids into account. NSPH describes conditions related to damaging cavitation, and that's where the NSPH curve comes in handy. To determine if a pump can operate safely in a system, the NPSH must be known for the largest flow and temperature within the operating range. The recommended minimum safety margin is 0.5 meters, but you may need a higher safety margin depending on your application. Pump design can also affect what the pump performance curve will look like. There are both flat and steel pump curves. Flat curves occur when there is a small change in head, resulting in a big change in flow, as you can see here. Steep curves, on the other hand, occur when there is both a small change in head and the flow, as shown here. That covers our module on how to read pump curves. We hope you enjoyed it.